So if we're looking at this picture, can you see that this is a right angle here? And even though it's in 3 dimensions, this is a right angle here because it's straight up. And because one person is due east and the other person is due south, can you see that there would be a right angle on the ground there as well? What we want to solve for is the distance between Leaf and Tanis. So on our overall diagram, there are 3 right angle triangles. What we're going to do is we're going to color code them on our main diagram and then draw them each separately to see what we can solve for, to see what would help us, so that we can solve for x. Oops, I want to go green to begin with. Let's do the triangle we're trying to solve for. Let's make that one in green. And what I'm going to do is I'm going to redraw it here, oops, in green, with an actual right angle. And this is the x we want to solve for. We'll do this triangle for Leaf here. I'll color code this one blue. But when I draw it over here, I'm going to draw it in 2 dimensions so I have a nice right angle. I'm going to label my 35 meters for my height and my 50-degree angle of elevation. And finally, for the triangle for Tanis, I'll draw that one in red. Again, 35 meters tall, and this angle of elevation was 70 degrees. So when we look at those triangles, the blue triangle and the red triangle both have 3 pieces of information, and they have at least one side. So if we want to, we can find every angle, every side of the blue triangle, every angle, every side of the red triangle. The question we have to ask is which ones are going to be helpful for us for solving for x on our green triangle. Because on our green triangle, we don't have any information other than the 90 degrees. So let's look at the blue one. What should I solve for on the blue one? The base. What letter do you want to use? I'm using x already over here, so I got to pick a different letter than x. Y. Okay. And on the red triangle, what side or angle should we solve for? The base again. And what letter do you want to use? A T? Okay. So if we solve for y and if we solve for t, we're going to get 2 more sides on our green triangle. Will that be enough? Yes. Because then we'll have 3 pieces of information on our green triangle, and we can solve for everything there as well. So we'll start on our blue triangle. I have this 50 degrees, so this y would be adjacent. The 35 would be opposite. So I set up my definition. I'll use tan. Tan of 50 is 35 over y. Multiply by y, divide by tan 50. divided by tan 50. Enter. 29.37. well, 368 dot 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 to show that we'll have it go on forever. I'm going to store this value, hit my store button, alpha, the letter y, because that's the variable that I chose. On my red triangle, same thing. I want to solve for t. T is the adjacent side to the 70. The 35 is the opposite again. So once again, we're going to use tan. Tan of 70 is the opposite over the adjacent. Multiply by t, divide by tan. Go to our calculator. 35 divided by tan of 70, 12.7. And I'm going to store that one, since we chose t, as the letter t. So now going back to our diagram, we figured out that this side is 29.3 and this other side is 12.7. So now we've got three pieces of information on our green triangle. With the information that's there, we could solve for everything. What would you use to solve for this one? A squared plus b squared equals c squared. You have to be careful that we use SOHCAHTOA when we have one of the acute angles. We'll never use SOHCAHTOA with a 90 degree. So the 90 degree that's here, we can't use it because the opposite and the hypotenuse end up being the same thing, and then it doesn't make sense to try to use a definition. So yes, we can use a squared plus b squared equals c squared. We had called this y and this t. So when we go to do 29.3 squared plus 12.7 squared equals x squared, the nice thing on our calculator is we've stored these things, so now I can just go y squared plus t squared, 1024, equals x squared. And we can take the square root of our answer, 32.0. What does it ask us to round to? Doesn't say. So and circle it because that's our final answer.